Right now, you are looking at the center of the Milky Way, and no human being has ever seen it like this before. This is a region so extreme, so violent, and so packed with mystery that scientists have spent decades trying to peer into it. And this week, they finally pulled back the curtain. A team of astronomers just released the single largest image ever captured by one of the most powerful observatories on Earth. And what it reveals about the heart of our galaxy is going to change how we understand where stars come from. Let's get into it. The observatory behind this image is called ALMA, the Atacama Large Millimeter / submillimeter Array. It's a collection of 66 high-precision radio antennas sitting at 16,000 feet elevation in Chile's Atacama Desert, one of the driest places on the planet. Those antennas work together as a single telescope, and they don't see visible light the way your eyes do. Instead, they detect radio waves, specifically millimeter and submillimeter wavelengths, which lets them see through the thick clouds of dust that block our view of the galactic center. And what ALMA just mapped is a region called the Central Molecular Zone, or CMZ. Think of it as the downtown of our galaxy. It surrounds the supermassive black hole at the Milky Way's core, and it stretches across more than 650 light-years. To put that in perspective, a beam of light would need 650 years just to cross from one edge of this image to the other. And here's a wild detail. This zone contains nearly 80% of all the cold, dense gas in the entire galaxy. That gas is the raw ingredient for making new stars. This new image, technically a massive mosaic stitched together from many individual observations, is the largest image ALMA has ever produced. Laid across the sky, it spans the width of 3 full moons placed side by side. The project behind it is called ACES, the ALMA CMZ Exploration Survey, and the team detected dozens of different molecules in this region. We're talking everything from simple compounds like silicon monoxide all the way to complex organic molecules like methanol, acetone, and ethanol. Yes, there's essentially alcohol floating around the center of our galaxy. Now, here's where it gets really fascinating. In the quieter outer regions of the Milky Way, we have a pretty solid understanding of how stars form. Cold gas clouds collapse under gravity, clump together, heat up, and eventually ignite into stars. But the galactic center doesn't play by those rules. The CMZ is chaotic. Gas is moving at supersonic speeds. You've got massive stars burning through their fuel at a ferocious rate and dying in violent supernova explosions, some so powerful they're classified as hypernovae. And yet, despite all that fury and all that available gas, some parts of the CMZ are strangely quiet. Scientists don't fully understand why. That's exactly what makes this data so valuable. ACE's principal investigator Steve Longmore, a professor of astrophysics at Liverpool John Moores University, believes this region may actually mirror what galaxies looked like in the early universe, back when stars were forming in similarly extreme and chaotic environments. Since those ancient galaxies are too far away to study up close, the Milky Way's own center becomes the next best laboratory. And this is really just the starting point. ALMA is getting a major sensitivity upgrade, and ESO's extremely large telescope, currently under construction in Chile, will push even deeper into this region. That means sharper images, more detailed chemistry, and a much clearer picture of how stars, gas, and black holes interact at the center of a galaxy. So here's my question for you. What blows your mind more? That we found dozens of organic molecules at the core of the Milky Way, or that after all this time, we're still discovering how stars are born? Drop your answer in the comments. And if you want to stay in the loop on discoveries like this, hit subscribe and turn on notifications so you don't miss the next one.